I'm an electrical engineer, taking engineering 6. I'm working in a group called Programming Panthers, and we're working on a digital watermarking attack project.
Hi guys, my name is Christian Hurd. I'm a University of California Davis student. I'm an electrical engineer, and I'm working alongside with Jonathan Chia and Amanda Ganell on our MatLab project of taking out a watermark from an image. Join us for this magical experience.
I'm going to talk about what we are doing and why we're doing it. Image watermarking is defined as the practice of altering some piece of data to embed a message into the image. Embedding a digital signal via audio, video, or image, which is what we're doing, with information which cannot be removed easily is called digital watermarking. So what that is and why it is used, it's to protect, identify, and track the digital media. So digital watermarking is based on data hiding. Since images can be copied from offline very easily, watermarking a photo has become significantly important to people to copyright their works of art to prevent theft of any digital images. The basic principle of watermarking is, there are very many stages in the watermarking process. However, for this particular project, we are focusing on the attacking portion. If we modify a watermark, it is called an attack. The watermark signal is then transmitted to another person. If this person makes any modification, then it is therefore called an attack. So the attacks that we have researched thus far for modifying the watermark are the least significant bit sharing, which is LSB for short, discrete cosine transformation, which is DCT for short, and pixel substitution. We are able to successfully implement the first two plans of attack, which is LSB and DCT. However, pixel substitution changed the quality of the photo by averaging the pixels around the watermark and replacing the watermark selected with the built-in function IM tool in MatLab with the average pixel. This attack removed the watermark but also ruined the picture. Therefore, since time was spent on this last attack, it is worth mentioning before we explain the first two attacks, which is LSB and DCT.
So our second attack was the discrete cosine transform, better known as DCT. The DCT uses a Fourier transform analysis. The Fourier transform analysis is a mathematical expression that can summarize a lot of things. In this case, it looks at the image and it looks at all the pixels within the image, and it's able to filter out any frequencies we don't want. Those frequencies we don't want are part of the water image that we're trying to filter out of the original image. Of the DCT function, the first image is a watermarked image that hasn't had the DCT function applied to it. The second image down is the image that has had the DCT2 function applied to it. The third image down is a grayscale version of the image, and it also had the DCT function applied to it. As you can see from the bottom two, the second one down is a lot clearer than the third one because it's at a higher threshold. But you can see from both images it does a pretty good job of taking out the water image.
The third attack method we implemented was least significant bit shifting. What least significant bit shifting does is overlaying the two images after having offset the pixels of each image. Because the least significant bit shifting attack offsets the pixels by a certain amount, it generates an output file that is twice as large as the original, so it's easy to detect how the significant bit shifting carried out. After that, the water is filtered in post-processing and the algorithm adds noise mask to the image to make it hard to attack. However, if we are able to capture the noise image as well as the watermark image, it's easy to reverse the attack. The results of LSV are shown below. In the initial watermark image, you can see that the IBM logo and the Google Plus logo are overlaid. These two images are exactly the same size. On the second image, you see that the noise extracted from the image is present below, but since they are not actually quite difficult to see the sparse pixels that litter the white landscape. In the final extracted image, we reverse the bit shift after we remove the noise, and we are able to extract the final files with 100% fidelity.
Group name is Programming Panthers, and